Hi viewers, I am creating these videos to support teachers of mathematics in helping their learners make sense of mathematical concepts and their associated procedures and processes. And today what I thought I'd look at is simplifying a ratio. And I'm going to use my Cuisenaire rods to help me with that. Now, there are a couple of different ways I can actually represent a ratio using these, depending on exactly what it is I want to highlight and what it is I want to move on to. So depending on how you choose to represent that ratio will make a difference as to how you look at simplifying it potentially, although both are, I think, very similar in terms of how they apply to simplifying. So let me take you through that and you'll see what I mean, hopefully. Let's look at a relatively simple ratio that simplifies. Let's look at the ratio 6 to 9. So I'm going to build that using my Cuisenaire rods. And for now, I'm saying that the white rod is 1, so that the length of each square is 1. So potentially the ratio 6 to 9 might look like that. And if you're familiar with using bar models for ratio or things like that, you might have set up bar models that look like this. And of course, this is just a concrete representation of those sorts of bar models with 6 to 9 there. Or alternatively, potentially, I might set that up with the 6 and the 9 next to each other. And that, I suppose, depends on whether I'm looking to highlight the relationship between the two separate parts or whether I'm looking to highlight the relationship between each part and the whole. So this obviously helps to see the relationship between the two different parts, the fact that this is 2/3 of that, the fact that this is 1.5 times bigger than that, things of that nature. Whereas this is much more geared towards representing the relationship to one whole, the fact that this is 6/15 of one whole, this is 9/15 of one whole, of the whole, should I say. And of course, that will have a bearing on how you look at ratio sharing or sharing and using ratio and things like that as well. So it's worth taking some time to consider how you actually want to represent those that ratio in order for sort of future use. The other thing to say is, of course, this is pretty much identical to how I might set up a fraction using Cuisenaire and how I might model fractions. And if you've seen any of the fractions videos, particularly around introducing fractions or adding or subtracting or dividing fractions, then this is a very similar picture. So again, that might help make that link that actually one of the ways of thinking about this ratio is to think about this as 6/9 of that, 6 compared to 9. What you potentially lose there, of course, is the focus on the whole, but then that's where this comes in. However, when it comes to simplifying, either way will allow you to sort of look at simplifying and make sense of simplifying a ratio in sort of a very similar way. And there are, broadly speaking, two ways that I might sort of model that, or two ways that I might prompt pupils into thinking about that. And one of those is, can I replace the green rod and the blue rod with a series of repeated smaller rods where I have to use the same number of rods in both cases? So in this case, I could replace the green rod with 3 red rods, and I could replace the blue rod with 3 green rods, and I could do the same thing clearly over here as well. I could replace the green with 3 reds. Oh, don't want the purple. And I could replace the blue with 3 greens. And then what we can see with that is that in each case, what I could do here is sort of drag it into this sort of picture, and I can do that in either case, or I can drag it into this sort of picture. And what we're seeing there, of course, is the 2 to 3 relationship. We're seeing here that although this has and we're talking about area in effect to represent here, so although this has an area of 6 and an area of 9, we can also see the 2 to 3, and we can see the 2 to 3. And in fact, we can see something about the multiplicative stroke divisibility idea in that ratio, the idea that I've separated this into 3 3s and 3 2s, 3 3s and 3 2s, or in this case with the area, it is width of 3 to create that area. So there's a multiplicative idea there with area and area modeling multiplication, and then 2 and 3. So we get the idea that this is either, depending on how you want to look at it, being divided into, each of those is being divided by 3, or that multiplicative by 3 there, that it's what's multiplying both of those numbers. What's a factor of both of those numbers? This factor idea of a factor of 3. What's a factor of both 6 and 9 that I could use? A potential alternative would be to, rather than say aim for the same number of rod in each case, would be to say, can I replace each of those with a single rod? So can I replace this with a single rod and this with a single rod, obviously repeated multiple times, and or similarly this or this? And you can see that I could replace that green rod and the blue rod. I could replace both of those with multiple 3 rods. So I'm using the same rod all the way through, and I could do that obviously in a single line as well. There's the replacement of the green with 2, and there's the replacement of the blue with 3. And again, we get therefore quite quickly this idea of the 3 being important there. Slightly different way we're seeing the 3 that time. The 3 is actually the length of the rod, so this becomes the factor. And again, potentially what I can do through rotating these rods in this case is create that same factor of 3 distinction. I mean, certainly if you're going to use this in a line or in an area like that, you've got to keep an eye on where the old 6 and the old 9 were, because it's, these can potentially merge together there. Obviously, if setting it up like this, well, then that's fine, and there's no sort of real issue with seeing that, because they're both on separate lines. But again, what we're getting from this is that idea of the factor of 3, or we can see it from here as well, the factor of 3, the fact that 3 is a factor of both of those numbers. So it becomes, rather than how, that being a length and that 6 and that being a length of 9, it becomes each of these being 3s, and then it's, rather than how many little white squares or how many 1s, it becomes how many 3s. How many 3s have I used here? How many 3s have I used here? Or, if this was now 1, what would this ratio be? If that green rod was now a value of 1, what would that length be? So that would be 2 and that would be 3. And of course, that idea of, particularly if you've watched some of my division videos and you've heard me talk about comparison for division, that question of what if this was now 1 is an important question in division, and particularly in using a comparative model for division. So if this was now 1, this would be 2 and this would be 3. Again, gives us that idea of the divisibility of 3 there, and dividing by 3. And potentially I could look at more complicated ratios than something like that. I could look at say the ratio 1/2 to 1.5. And this would require me to understand a bit more about representation of fraction in this case, and the idea that, okay, well, if I want to represent the family halves, then I need to define the red rod to be my whole, so that is going to be 1, and therefore this is 1/2, and this is 1 1/2. And immediately I can see from that, the 1 to 3 relationship there. Again, what if this was 1 whole, this was 3? Or I could go through the same mechanical steps of saying, can I replace these all with the same color rod? And it would look something like that. Yeah, or can I replace it with an equal number of rods of the same type, which in fact I don't need to. Here I have 1 rod and 1 3 rod. So that sort of mechanical idea can be brought back for something like that. But in this case, it shouldn't really be needed. We should be able to see the 1 to 3 relationship there very quickly. And again, what we're talking about here is, okay, if this became 1, what would this be? But then focusing on, okay, what happened for this to become 1? Well, it did have a value of a half. It now has a value of 1, so it's doubled in size. So this has doubled in size, this has doubled in size. And potentially, we could go as complicated as we like with that, provided we've got good representations and good ways of thinking about fractions and decimals using this sort of representation. We could have 2 fractions with unequal denominators there, provided we can represent both of those. Very simple, quick example, just looking at a half compared to 1/3. And so in order to represent those, it now becomes a fraction representation situation. I'd need to use this rod. Well, I wouldn't need to use that rod, but that's the smallest rod I could use to represent both of those, in which case this rod would be 1/2. You can see it there. That is 1/2 of my hole. So this is 1. This is therefore a half. Similarly, this is therefore 1/3. And once I get to that, I can immediately see the 3 to 2 relationship there, can't I? I can see that this is 3 and this is 2. I mean, if I wanted to go through that mechanical process of replacing it with 1s, then I could, but this is the 3 to 2. And then we can look at, okay, well, that was supposed to be a half. How did that become 3? Well, a half becomes 3 through multiplication by 6. How did that third become 2? Oh, it was also multiplied by 6. So actually that both, and again, that multiplication by 6, because this 1 whole now becomes 6. So that's potentially how I might start to look at the concept of ratio and simplifying ratio in particular with learners using a concrete manipulative, in this case Cuisenaire rods. As always, I'd like to say a big thank you to mathspot.com and its creator, Jonathan Hall, for this fantastic website that houses all of these virtual manipulatives that I use to bring these videos to you, but doesn't just house the virtual manipulatives, of course. It houses a whole wealth of sort of resources that teachers of maths can use to support their learners and to work with their learners. So if you haven't yet had the opportunity to go and have a look at that website in detail, then please do. You will thank me for it, I can guarantee. And again, if you are interested in using visuals and manipulatives to support sense making with your learners, then please do feel free to check out my website. My website is the website visiblemaths.co.uk, and among the many things you'll find on there, you will find a link to a section on that website called Visible Maths Book. And that book has been published. It's been out now for a good couple of years. And the publisher is Crown House Publishing, and there's a link to on my website where you can view some sample pages, and if you feel like it would be useful, you could place an order. I'm going to be creating these videos throughout lockdown and potentially beyond. So if you feel like there's a particular concept or process or procedure that you would want to see modeled using manipulatives or visuals, then please do get in touch and I will happily get about creating it for you. Thank you very much for your kind attention today.